Hi, I just wanted to do a quick video on special products in Chapter 4, Section 6, mostly because of Chapter 5. When we get to factoring, which is basically taking a product and an answer to a multiplication and changing it to a multiplication of two different things, or factors, right? Factors are parts of a multiplication. Well, these special products are more useful when we're dealing with factoring. So I'm going to talk about Chapter 5 a little bit, but hopefully when you get through this or do this assignment, you have tried to use these methods that they're showing. You know, paying attention to the book is pretty important. So the first one that's special is when we have a product of two binomials. They talk about, you know, the distributive property. They went through that you could take x plus 5 times each term of the x plus 4. So you take x plus 5 times x, and then you basically do a monomial times a binomial and so on. Well, what happens if you follow a certain pattern? These two middle terms that are in this order, right, are like terms, so they add together. You know, so you have basically with the distributive property, I can say that x is a common factor there, and I can say this is 4 plus 5 all times x and get 9x, or combine like terms. Well, the pattern is to follow this first times first, outer times outer, inner times inner, last times last, or FOIL. And here's the FOIL method illustrated. You know, it's a mnemonic to help you remember that. And that works almost all the times with binomial, or it does with all binomials. And that's, they show you the easier thing first and something that works for everything, and then they're going to give us some special things that happen. And it doesn't, you know, they don't have to be, you know, degree 1 polynomials or binomials in this case. So they go through this, the FOIL, FOIL, and you get like terms. Sometimes, in this case, you wouldn't. You know, there's no like terms here to add. So you end up with this polynomial with degree 3 with 4 terms. So get through these examples. When we have binomial time binomial, there's the next special thing that happens is when we have a sum and a difference of like terms, and in the sense this x and x are the same, 5 and negative 5 are the opposites of each other. When this pattern occurs, the process of these middle terms or like terms goes to 0, and you end up with a binomial. Well, the binomial is what it's really named for. When we get into Chapter 5, you have when you have a two-term or a binomial, when I'm looking to factor, one of the first things I should check is this something squared? Well, x squared is something squared. And is 25 something squared? Yeah, that's 5 squared. And if I have a difference or a subtraction of those two, it will factor into each of those terms with the negative portion being opposite, like that. So you get this pattern called difference of squares. This something squared minus something squared. The next pattern is this squaring binomials, which if I have like x plus 3 here in this first statement to the 2 power or squared, you know, I could use FOIL again, and I'd end up with two of these like terms in here that are exactly the same. In fact, I get two of them, 3x and 3x, so I'd end up with 6x. And then they show us here with a minus 7. Well, the pattern is, in the trinomial result or product, is the way to check this, and it's called perfect square trinomials, is the first term something squared, is the last term something squared, and then I check the middle term. If I took what was squared times each other and doubled it, or take it times 2, does that fit the middle term? And if it is, then it factors into a binomial squared. And like I said, you could write this out, and my guess is a lot of you did this. You wrote it out as a multiplication and used FOIL, but you may have missed the idea of this pattern, which you'll need for chapter 5. They have some cautions here. One going back here. This diagram, you know, good problem solving strategy almost in anything, but especially in algebra, is if you can draw a picture of it, do that. And you can actually draw a picture of things squared by drawing a square, right? And you can have this a plus b, the quantity squared. I could draw this square with a length of a and a length of b. This length of this side would be a plus b, and the other side would be a plus b. Well, if I broke that down into other rectangles, in this case a square and two rectangles, you can see the pattern here. I get the first term squared, the last term squared, and then I have these two of these ABs, or A times B. There's two of them, so you get 2AB. And that visual can help you, hopefully help you see that pattern. So like when I see things like this, if I look at A, is this something squared? X squared? Yes. Is 1 something squared? Yes. If I took 1 times x and doubled it, do I get the middle term? Yeah, 2x. So right now, I know this is a perfect square trinomial. Actually, they tell us it is. But that's what you're going to look for in chapter 5. So I know that this is going to be x plus 1, the quantity squared here, b. Okay? And when we have two polynomials, it's kind of summed up here. If I have this pattern, I end up with difference of squares. If I have a binomial squared, I end up with this perfect square trinomial, which works for both addition, subtraction, which are really not anything different. And if none of those work, or you don't see these patterns, then it says use FOIL. And they really want you to practice this way. I do want you to practice it this way, because that's exactly the way we factor. We go, hey, is this binomial? It's a binomial. What are the things easy to factor? Well, if it's a difference of squares, I can factor it. If I have a trinomial, I look and say, hey, is this a perfect square trinomial? And if it is, then I can factor that. And if it isn't, I'm going to use something called anti-FOIL, and then we'll go through grouping too. And that's about it. Again, just a quick thing. It's easy to just do your work, get them right. A lot of times you may have gone through this whole assignment, got everything right, and but not practice those key things to look for, or those patterns to use, which will help you for factoring.